Everyone, this is Tim Dearlove from DigitalOcean. Welcome back. If you've attended one of our previous YouTube live sessions, we've done a bunch over the last couple of weeks on a variety of different topics. And we're really excited about today's topic. For DigitalOcean, reliability and the ability to ensure that whatever you're working on, be it a website or a web application, an enterprise mobile app, whatever it is, we want to make sure it's highly reliable, highly available, that you're serving something that is accessible to everyone that wants to access it. So I think this presentation from our partners, Snapt, is going to be really important. And we're really lucky to have Dave Blakey on the line with us today, who is the co-founder and CEO of Snapt. He has a lot of experience with DevOps and growing company. He's based in South Africa. He's a big member of their startup ecosystem and trying to expand their tech hub. So if you're from South Africa and you happen to be here, wave your hand before we turn it over to Dave. The first is, as always, feel free to ask questions in the chat panel, which if you're on the desktop is to your right, and if you're on the mobile device, it's down below. In general, we're going to try to save as many questions as possible for the end, for after Dave gets through his presentation and his walkthrough of actually setting up multi-location load balancers and using some of their platform to demonstrate that. But if there is something particularly relevant, we'll answer it in real time. Second thing is, this is going to be recorded. It's going to be live on our YouTube channel after the fact, so feel free to tune in after if you need to jump midway through or anything along those lines. Dave does have a couple slides that go with his presentation, so we'll make sure we link to those after the fact as well. So with that, Dave, I'm going to turn it over to you, and I'll let you get started.
Awesome. Thank you, Tim. And good morning, afternoon, and evening, everyone. And thanks for joining us. Yeah, I think it's quite a popular topic now, obviously, multi-location load balancing. And it's something that we do a lot with DigitalOcean. We ourselves do it, and then obviously a lot of our clients do. So I'm going to go through just what that is, really, why that exists, and how it's achieved, how it looks, and then we'll actually do a setup in DigitalOcean using some of our product stuff, but also talking about other ways that you can do it, etc. And the benefits and some of the caveats and what you need to be aware of, etc. So it should be good. I'm going to share my screen in a second. Let's get that open. And great, let's get started. So, multi-location load balancing for DO, right? Firstly, what is multi-location? Now, this is kind of an obvious question, obviously, being in multiple locations, but what's the real reason? What are the trends? Why are people doing it? What does it involve? So as you will know, as DigitalOcean users, when you launch your servers, when you launch your droplets or your clusters, whatever it might be, you're deploying them into a data center somewhere, right? And this is true with your own hosted equipment. It's true in public cloud. It's true in private environments. They're ultimately sitting somewhere. And there are multiple reasons why you might want to deploy your app or your backends, your APIs, your website, whatever, to multiple places. The first one, the most obvious one, is high availability. So this is often done in a disaster recovery kind of way, where your primary data center might be in New York and your backup data center might be in another state. And if the primary was to fail, you want to move traffic to the backup. It's also quite common now, obviously, especially in bigger companies, to want people to go to a close data center, right? Something nearer the edge, like send users on the West Coast to San Francisco, users on the East Coast to New York. And if New York were to be offline, then send everyone to the West Coast, or geographically even larger, right? Like perhaps European users to London and so on. And that has some natural disaster recovery obviously built into it. And you may also have situations where you have different services in different locations, right? Different stacks, perhaps a different website, or a different set of APIs that are available there in a different data center, etc. So it's really talking about the idea of having your applications present in multiple data centers, and how users interact with that, how they get there, how you leverage this ability that you have now, that you're highly available and resistant really to pretty much any type of fault, and how the communication all works around that. So for those of you that are somewhat familiar with this, the biggest kind of word in the space, I guess, is GSLB. Now, GSLB stands for Global Server Load Balancer, and it's really talking about a smart DNS service, right? So load balancing is what we do, really. And typically, a load balancer sits with your origin service, right? So it sits right in front of your app servers, and users come to the load balancer, and then their traffic is passed to, whichever app server is responding the fastest or has the least connections, and you move people off of one if it goes down, etc. But in the event that your entire data center was to go down, or your rack, or your Kubernetes cluster, whatever it might be, the load balancer would go down as well, right? Or there's an internet outage that takes out the whole of New York, whatever that might be, your load balancer is now fallen fault to the same problem. And eventually, as you go up the stack, you reach a point where you need a system that can respond from multiple locations, that can respond intelligently from multiple locations, and that's easy to kind of replicate and reproduce around the world. And it turns out that DNS is the perfect way of doing that. It's not perfect entirely in that there is obviously a time to live with DNS records, but that can be quite short now and it can be quite efficient. And what a GSLB does is it responds to DNS queries for your website. So when someone says www.snapt.net, it will respond with an IP address like you expect, but with some rules set around it, right? So, well, is this IP I'm about to respond with online? Should I check that it's responding to HTTPS requests on port 443? At the same time, you can also say, well, let's base it on who is this person that's asking for it, right? What is their IP range? Should I respond differently based on IP range, or should I respond differently based on their geographic location, like sending European users to the European data center and sending Americans to the American one, or West Coast and East Coast, and all these kinds of things. And that's largely based on two things: the health of your origins, so your actual web servers, right? How loaded are they? Are they online? Is it connecting? All that kind of thing. And then who the user is, being what type of requests are they sending? What are they asking for? What's the domain? And where are they coming from? And where might we want to route that? These will typically also have some kind of failover built in, right? So if I've decided that you should go to the European data center and that happens to be unavailable, then I might be able to send you to a backup. And in this way, you can really achieve the goal being multi-location load balancing, right? So in a DigitalOcean example we're going to look at just now, we've got New York and San Francisco, and these are availability zones for us, where we want to say, send users to the closest zone always, but ultimately we're willing to send them to either, should there be some outage or connectivity issue or something like that, in order to have this highly available app, as well as to scale better. So we might have performance constraints where only a certain number of users should go to a certain data center, and we might be much busier in the early morning on Eastern time than we are, in the afternoon, and so on. And so it takes all of that into account. So when we look at kind of more modern stack network diagram, if you will, it's not very detailed, but of how people are often deploying things today, and you can ignore the kind of the Nova text around in the meanwhile, right? You also see multi-cloud strategies, right? So what you can see in this example is on the left, we've got DigitalOcean as an example, and we've got a stack of servers, A, B, and C, that are serving our various apps and services and databases and whatever they might be. And we're in London and we're in New York. At the same time, we might be in another cloud provider or a custom data center that could also be in London and New York. And, we've got services in both so that we're mitigating the risk of failure, that we're, might want to move different workloads between different environments depending on different services and so on. And you can kind of scale this out to multi-location, multi-cloud, multi-platform load balancing for your apps, right? And that's what it looks like in a lot of larger enterprises. Will have this type of breakdown, right? This type of inbound access to their systems from the client. And at the top there where you see Nova destination, that will be your GSLB layer, right? That's your client speaking to a GSLB and ultimately resolving to a data center based on these rules that I spoke about. So now, when you look at GSLB, there are a bunch of different ways of doing it. Obviously, one is called Nova Destinations, which we'll use for this DigitalOcean demo, our product. There are also, open source methods. You can do it with DNS servers, and you can sometimes script things yourselves. And there are others that have health checks involved. There's third-party DNS providers that can do it. There's a lot of options around there. But one of the kind of big areas that we focus on a lot, obviously, is integrating that with ADCs. So for anyone who doesn't know what an ADC is, it's really load balancer plus, I guess. So load balancer being the entry point into your application, your services, the thing that makes sure that the requests are safe and that they're going to an online server, that they go to the fastest server, that they get back to the client as fast as possible. So it's a load balancer, a web accelerator, and an application firewall, and then often a GSLB is included in that. So it takes care of your multi-location routing and recovery, your scaling up, your scaling down, your security across the different cloud kind of locations that you're deployed in, etc. Now, what we're going to see is kind of our implementation of this, and something that's very important in that when you look at designing this type of thing is centralization and avoiding having your configurations and the important kind of components of the setup sitting in the data plane. So what I mean by that is that you want to be orchestrating, configuring, controlling, and monitoring this from a central location so that you can easily lift and shift load between locations, right? So when you say, I want to disable TLS 1.0, SSL, right? So you turn off an older version of the protocol. You want to disable TLS 1.0, and it should happen in the New York data center and the San Francisco one, and any on-premise equipment you have, and around the globe, right? So it's very important to have centralized control for that, and that's what we'll see. And that really enables your multi-location load balancing a lot better when you look at, how your GSLBs interact with that. But we're going to see a real example of that, actually setting it up and, load balancing some web traffic, etc., across multiple data centers in a second. Now, some of the highlights that you'll see of using Nova and DigitalOcean. Nova is very tightly integrated with DigitalOcean. So it allows things like auto-scaling on DO, service discovery. So there's like a big tendency to move away from static configurations, as you guys will know, especially in DigitalOcean. It's very easy to scale up and scale down, right? You can very easily through the API launch more versions of your services, right? Or you could be using Kubernetes, or you can take an image and launch it. Launch 10 more of your web servers in New York, or you could take that snapshot, move it to San Francisco, launch 10 there, etc. So you're going to see a lot of that, multi-location deployments and routing, the ability to self-repair these types of services in DigitalOcean, how you can run your own application firewall, WAF, web application firewall, right? So to secure you against threats like SQL injections, cross-site scripting, that sort of thing. And how you get detailed analytics and anomaly reporting for that. And then the last thing I wanted to mention, especially for the webinar and kind of developer community watching this, is that everything that I'm showing you is actually available in the community edition. So it's not paid. It's entirely free, and you can use this with DigitalOcean and deploy. So it would be great to see some people start to play with it, I think. Now, without further ado, I'm going to switch my stream to my browser and have a look at our DigitalOcean account that we've set up for this demo. Give me one moment. Great. So here you can see our DigitalOcean control panel, and you'll see we've got 4 droplets online. You can see that over here. And they've each got IP addresses. I've named them in such a way that it's easy to tell, but you can see these 2 are in San Francisco, right, SFO2, and these 2 are in New York, NYC1. And if we were to go to any of these, they're just a standard LAMP stack, right? So nothing fancy, just a little logo and the text hello. And that's what's running on all of these. So if I go to San Francisco instead, we can see there the same thing, right? But for our demo, we've got these 4 web servers, and there's 2 in New York and 2 in San Francisco. And obviously that can be scaled up to any number, but the real idea is that we've got them in multiple locations. And we want to leverage that, right? To have these things be highly available and to be able to to scale them if we want, reduce them if we want, whatever might be kind of our goal. Now, what we're ultimately going to set up is a DNS address that we can go to that will take us to one of these 2 data centers, as long as they're online, and that those data centers will make sure that our requests are secure and safe and so on. And if they are, they'll be sent to the fastest web service, right? So in our example, these could be like our API backends or our website, e-commerce store, whatever it is. And we want to now grow this on DigitalOcean to being in multiple locations. And you could deploy this to anywhere you wanted, right? So you could also have like 3 or 4 or 5 locations. We could also look at London, Asia, things like that. Now I'll switch to my Nova dashboard here. So you're just seeing my account and some of the kind of the view of what you get on Nova. Now, I don't want to go too much into the detail of setting up nodes and things like that. But what I will show you first is that you can connect to your cloud providers and that we have connected to our DigitalOcean account here. So you see the exact same thing here. SF Web Server 2, 1, New York Web Server 2, and 1 here with the same IPs. And again, if we go there, we just see the Snapt hello page, right? But one of the important things is that you'll notice here it's picked up that they're tagged as web servers. Now it's great on DigitalOcean, you guys will know, it's very easy to tag systems, right? So I could come in here and add, additional tags, like we might want to say that these are SFO ones. And we could tag both of those as being an SFO. So let's edit the tag there as well. And then we might be able to do something separate. We might want to group those in a different way or something like that. But right now they're all tagged as web servers. So you'll see that here. And what's great about that is if we were to scale that up, right, we might not want on our GSLB infrastructure, our multi-location load balancers, we may not want to have to manually manage those, but we might have, a variable amount of systems, right? Like maybe during the day there's 10 web servers and at night there's 2, or, we sometimes scale up London and scale down San Francisco or whatever. So we want to be able to point to these without using their IP addresses only. And we can do that with tags on DigitalOcean. Now, the next thing is that you can deploy Nova directly into DO. So what I'm going to do here is say, okay, I want to deploy SF ADC, and we'll stick this in San Francisco too. We can just use any droplet size, obviously, but we'll stick with this one, and then that we can launch that, right? So that's going to provision a Nova droplet in SFO2 for us that will come online, and we'll then actually be able to use that as an ADC in our DigitalOcean tenant on the West Coast. At the same time, I want to set up our New York ADCs. So I'll say New York 1, but perhaps we want 2 there, right? Like maybe for scale, we need extra. So we could launch that, and that will then come online as well. So we should see now that we've got 3 droplets launching. And if we have a look on our DO account, we can see them there coming online already, and they'll be ready to use in like about 60 seconds. While we're doing that, so they don't waste any time, the next thing we want to do is define these backends, right? So like I said to you, we want to use the tags on these servers to send traffic to. So we can come in here to ADC backends and we can create them. Now we could do simple. Simple will just let us put in IP addresses and ports. But like we described, we want to do a cloud API based one, right? So we can say DO demo backends here. This is going to be our website where we ultimately send the traffic, and we can submit that. We'll say we're sending them port 443 traffic. It's their HTTPS web servers, right? And we'll look on our test DigitalOcean account and we'll use the web servers tag. So with this, you don't have to manually put in the IPs now. Nova will just communicate with DigitalOcean to find out whichever servers should be sent that traffic, right? Because they're web servers. And you can see the droplets are now online and good to go. So the launch is complete and we'll be able to use them. Now we've got this backend here called DO demo backends that will automatically send the traffic to anything on DigitalOcean on our account that's tagged as a web server. Now we can actually create an ADC. And then once we've launched the ADC, we'll be able to do the multi-location load balancing, right? So you could use any type of load balancer there as well. You could use your own custom HProxy one. You could use a solution like Nova. You could use a third-party one, whatever it might be. But when we create this, you'll see I'm just going to say we want an SSL termination one. We'll say here ADC SSL in, maybe, naming conventions, right? And we'll say SSL termination and submit. So now we're configuring an SSL termination ADC. Why are we terminating it? When I'm speaking to port 443 on the backend service, right? Like it's SSL, so why don't we just pass it through? Well, because we want to do a bunch of stuff. We want to check the health of that. We want to see the response times from the servers so that we can understand where the traffic should be going to. We want to use the WAF to stop like SQL injections. And, if it's encrypted, we can't do that, right? So what we can do now is we can say, okay, we'll do all the defaults, round robin load balancing. We don't need to go into all of that. And then we'll use an uploaded certificate. So I have a wildcard here loaded for snap.net. So it's star.snap.net. So when we actually go there, we'll have to accept the certificate because we won't use a snapped host name for this. But you can also provision Let's Encrypt certificates here, right? So like if you've got your server sitting in DigitalOcean, you could say, well, Let's Encrypt, and it's just going to be like my domain. .com or whatever you might want to do, but we'll come back to just using our wildcard here, right? But you could set that up however you want. You just accept the terms, etc. The next thing I'm going to do is say where we're going to send the traffic. So we're going to send it to our DO demo backends, right? The web servers tag in DigitalOcean that we've set up. You can send it to multiple places as well. So these are the types of things you can do with an ADC, right? You could say, all right, well, if it's partnered.snap.net, we'll send it there. Otherwise, we'll send it to the demo backends as a default. But for our use case, we want to send everything to our web servers. Some health and protocol checks. How do we check that they're online? Things like that. And then the performance and security is where I'm going to turn on a couple of features for us as well. So we can do things like say, well, we'll cache this content, try to accelerate it. SSL, this is quite important. So we'll redirect HTTP to HTTPS, obviously. But we want to re-encrypt, right? We want to speak to port 443 on the web servers. That's the port that we put in. So, even though we've decrypted it, we'll re-encrypt it again so that it stays secure across the wire. Although, the launch of recent launch of the banner's gone from the top of private networking DO makes a lot. You can actually terminate at the ADC and not have your web servers worry about that. But I'm going to re-encrypt. And then for security, I'm going to turn on the WAF, like we mentioned. I'll turn on some of these protections. What they do is monitor traffic coming through. Like, so, if you get a huge spike of 404s going back to clients, we know it's probably a vulnerability scanner, things like that. But I'll turn that on. And the rest of the options we can leave blank. You can do things like geofencing, so even though you're routing based on country, you could also say, well, don't ever allow anyone except for IPs that are from the US, maybe, and also the UK. Perhaps you might want to do. On the reverse, you could say, well, allow everyone, but don't allow, whatever, right? Don't allow Georgia and Germany, or whatever locations you might want to block. But we'll just leave it as default, and then we can save that. So we've got this configuration now that we've defined, right? We want to accept traffic and we want to send it to the tag called web servers in DigitalOcean, and we can then deploy this, and we say, cool. We want to put it on the 2 ADCs we launched in New York and on the 1 ADC we launched in San Francisco, right? So we've got 3 ADCs. You'll see here these 3 systems. Those are 2 New York ones, right? Here's our SFO one. And we're going to attach this there. So we want to be able to accept the traffic and have it automatically load balance to the web servers that are sitting in its environment. And it will then be able to accept the traffic from the GSLB component, right? Nova destinations. Now, with a GSLB, you could send the traffic directly to your web servers, but you really want an ADC because you want something that's going to be able to hint to upstreams that there's like potentially it doesn't want traffic for various reasons, things like that. So it will be able to do things like have a capacity limit, and if it gets that capacity limit, it can tell the destination that the GSLB that it doesn't want any more traffic, even though the web servers are technically online and things like that. But that's obviously a more complex setup. But you could, in theory, just send the traffic to web servers, which I'll show you how to do. And these are online now. So before we get fancy and send traffic via a GSLB to multiple locations, let's send a request to the first ADC that we have in New York, right? So you can see that none of them have any data. But if I was to come here and say, okay, well, this is its IP, right? So we can see it there. I can send a request there and we should get an SSL error. So because of the certificate, the snap.net wildcard, so we can now accept that, and then we get to the same page, right? So we know that our ADC is online. We know we can send traffic there and it'll go through. And now we start to see that data, right? So we saw a spike of requests there. We can see that we've had 4 requests go through, a little bit of data. It'll monitor the latency and stuff like that. So we know that it's starting to work. We can see we wound up on the first kind of demo backend there. And, you know, whatever else is going on, we can look at what IPs are connecting and things like that. And we can also test that the firewall is working, right? So if I was to say, well, let's request test is etc password. Good way to test an application firewall for anyone who ever wants to test if one exists. Is definitely going to get blocked. And you can see there that it's been forbidden. But, you know, in a real world example, obviously it's not going to be something like that. It could be, you know, we might be dealing with the users table, right? And then perhaps someone comes along and says like, okay, let's try an SQL injection. So instead of that, let's delete from users, right? And it would then obviously block that because that's like a much more likely attack that you might see. So now we're pretty happy that that's set up. We can look at, you know, our WAF blocks to make sure they're coming through. Like here you can see MySQL was picked up, right, etc., and, you know, so on. And we can configure that and monitor them. We'll start to get some graphs there and so on. And if we want to, we can look at the specific logs. That helps with testing as well, right? Like when we're sending traffic through and we want to see the data. So there you can see my GET request. We can switch the style to maybe is going to make it easier for when we actually send the traffic through the GSLB. So like there you can see that was blocked and so on, right? Now, the next step, well, I suppose really the next step should be just to test the other side as well. So like we know that New York is working. We can go to San Francisco now as well, because we want to check that both of these places work, and then we get the same error. And so we know already that it's working, right? Because we've gotten the error, but we get to the website as well, and we can come in here and say, okay, well, this is working as well. So now we've effectively deployed ADCs into 2 different DigitalOcean data centers, right? We've got New York and we've got San Francisco, and we're managing them here centrally, which is great. And now we want to say, okay, how do we get the traffic to them? Because there are a bunch of things and reasons to be concerned, right? Like the first thing is we know we've got 3 IPs. So how do we get the traffic to the 3 IPs? And if we were to do a DNS address that just points to all 3 IPs and one of them was to go offline, then like a third of our users will just get an error. So that's obviously not good enough. But the other thing is that you can actually auto-scale in DigitalOcean. So you could say where I deployed ADCs, we could instead say DO scaler. We'll do a cloud autoscaler. And here we could say, okay, use our DigitalOcean account. And we're going to be in New York for this one. And we're going to have that size system. But we want to run at least 2 and not more than 10. And what that will do is automatically provision however many droplets are needed to handle the load that's coming in, right? Like if you get a big burst of traffic, things like that, it'll scale up or it'll scale down when it's quieter and so on, right? Just launching and reducing droplets, but it'll also auto repair them. So that really then speaks to, you know, you can't use static IPs, right? Because what if the IP pool changes? What if one is deleted and repaired? You know, anything could happen. And so you really need something that's intelligently routing your traffic there. And that's where your GSLB comes in, right? The core kind of foundational thing that's going to run all of this for us. And here we say create. So we're going to say here, demo, DO destination. And this is my organization name. So when you sign up, you get an organization name. Ours is Snapt. Imagine that. .novadestinations.com. So if like, you know, you signed up and your name was DigitalOcean, it would be digitalocean.novadestinations.com. And it's going to provision this for you ultimately that you can send your traffic there, right? With an alias or a CNAME. So you can point like www.mysite.com to this and then that will work, right? So here we can say, you know, whatever the slug we want, but let's just say demo DO ADCs, right? Simple enough. And we could put in IPs. So when I mentioned that you could manually configure your IPs if you wanted, you can totally just put in a comma separated list there if you want. But you could also say, okay, we're going to send it to the 2 New York ADCs and the San Francisco ADC, right? And then we'll pick up that those are Nova ADCs, obviously, and then, work better with them, like pick up if their upstreams are all down. So for example, like if all the web servers in the location are down, your load balancer needs to tell your GSLB, yes, I'm still online, but none of my web servers are, so don't send me traffic, right? And so it handles all that kind of stuff for us. And we can say submit. So it will now provision this for us, right? You see here, demo do adcs.snapt.nova destinations.com. And if I was to go into another one, like this one, we'll see, some of the stats that you can get here, right? So these stats also feed into things like the autoscaler and, how it load balances and all that stuff. But, you get like kind of details on your DNS load. And we can look at this one, obviously, but it's empty. But we can go to this host and we'll see the same warning because we're going to the wrong domain, but if I pointed www.snap.net to this, then that would obviously work. And then we proceed and then we get the same page. Now, what this is doing for us is automatically sending it to whichever nodes are online and can accept that traffic, right? ADC 0, ADC 1 in New York, and San Francisco ADC 0, right? And if we were to delete that, build a new one, whatever we might want to do, we'll get that we'll get an entirely new one and it will automatically update. So you can see like that's the IP address of that one. So we could go there manually, but we don't need to because now we've got this DNS address that's looking it up for us automatically. And if I was to say online NS lookup, we can see what that actually looks like, right? So we take this domain name of ours and we can put it in like so, delete the HTTPS stuff from it and say go. And how does one say that they want the actual IP records on this? There we go. You can see here it's responding with all three because all three are online. So those are the places that will send us. Now we could configure things like, when to send people where and why and so on. But that's online now and it will handle failures, right? So it will automatically adapt to a system being deleted, like if our San Francisco one was to go offline. So, if I was to come in here, for example, and shut down this ADC just to simulate it failing, yes, turn off, that's fine. And as soon as it shuts down, we would then remove that from the pool, right? So we would see that this node goes offline. It's still turning off now, I think. So we're not going to see it immediately. No, it's picked up already. Shut it down. So that's gone offline. And the destination will update, right? You can see it's being picked up as disconnected. And so the destination's only going to send it to 2 out of the 3 nodes, because it's not available. And if we turn it back on, it's going to pick up that it's come online again, and the traffic's going to go through there again, right? And we can manage that and see all of that. We've now got a WAF in both locations, so it's being secured, and we don't have to worry, about there being a connectivity issue on either side, etc. It takes care of all of that stuff. From there, you get quite complicated, right? You can start to do things like say, well, we want to route to the nearest hosts. We want to send certain people to certain places and certain events, or at certain times we want to do things. And you can get even more complicated when you get down to tooling and do things like update destinations or your GSLB with your API, like you want to shift traffic. Maybe you're doing a new deploy in your San Francisco data center. And so you say, okay, let's just send 5% of the traffic to our nodes back online to San Francisco and send 95% of our traffic to New York. And we're going to deploy to SF our new version of our app or whatever, and it will just test that, and all that kind of stuff, right? You can do and you can shuffle things around, etc. So it's a very powerful tool at GSLB, and it's very enabling of being able to load balance to multiple locations and multiple providers, etc. Right? And that's a quick look at what it looks like to set up an ADC and to have a GSLB address that sends that traffic to multiple locations, and how you use that and how you monitor it and how you would see the health of it and so on and things like that. If there are any questions, please go ahead and ask. The one thing I did want to mention is, like I said, this is everything I've shown you is available entirely for free. So you can just sign up and play with it if you want. And we're obviously always available to help and answer questions and things like that. But yeah, I mean, it's great to be able to just deploy it and use it in DigitalOcean and integrate with it. I use it myself personally as well. But yeah, if there's any questions, happy to answer.
Thanks, Dave. And a reminder, if you do have any questions, feel free to ask those in the chat panel. And if you don't have questions live now, obviously, we already linked to it, but we'll link to it again. We'll link to the marketplace listing for Nova from Snapt, and we'll also link to their website as well. So plenty of ways to get in touch with them afterwards. Dave, I think one of the things I was curious about, so you obviously, we centered this talk around DigitalOcean. If you're a multi-cloud developer or business, can you speak a little bit to the importance of using an ADC and maybe specifically Nova? How do you guys help those particular customers? Since we do have a lot of customers that are using multi-cloud approach.
Yeah, absolutely. I mean, it's bigger and bigger now, right? There's so many reasons to do it. And one of the concerns in that area is kind of abstracting your so I don't want to use too many like kind of buzzwords, but abstracting your ingress from the provider, right? So like the way you're receiving traffic is, so as I've shown you guys now, your destination for your traffic is really generally going to be an ADC, right? It's going to be something that's providing the availability and security for that inbound traffic. And now in different clouds, there are different implementations of ADCs, right? From a simple load balancer up to a load balancer and a WAF, or whatever functionality that they may be providing, and you can struggle if you are in multi-cloud locations and then depend on the cloud-specific tooling around that, right? So what's great with DO being a platform like it is that it's very easy to deploy things like Nova, because you can then say, okay, well, I'm going to deploy this Nova ADC into DO and also into cloud provider B and cloud provider C, and you get the same configuration, the same security, and you manage it centrally across both of your kind of infrastructure hubs, so it's very easy to then move loads into DO and things like that. And what that also enables, like when you talk about multi-location, it's funny, like we're talking about sending traffic to production, multi-location, but the issue you're raising is like, well, the vendor neutrality of having like a third-party service to handle your inbound traffic. And what's really nice about that is that you can deploy a node in your CI/CD environment, or like in Vagrant. I mean, like we have nodes running in Vagrant on our dev boxes, right? And so when we do like our testing, like our feature tests and automated tests and things like that, they actually go through our WAF. And they go through simulated environments that are like our production environments. So that's great from a development point of view. Like how many times, I don't know, it's certainly happened to me in my old life, but you've written something, deployed it, and then like the WAF has blocked it, or in production, the environment is different, and so that's great.
Gotcha. That makes sense. And again, the nice thing about DigitalOcean, or potentially the curse for one of these, is you have folks building everything, from something, a very simple website to an enterprise grade web app. So it's good to get your perspective on if you are in that multi-cloud space, sort of where Nova fits in and where ADCs fit in. So I think that's it, Dave. I don't see any other questions. I think that speaks to how well put together your presentation was and how thorough it was. So I want to say from the DigitalOcean community, thank you for going through that. And again, one of our core tenets is reliability and availability, and I think this hits on that tenet and shows how important it is, and a creative approach to really striving for high availability. So Dave, thank you so much again. If you are attending, Dave mentioned this a few times, I'll mention again, they have a marketplace app in our the DigitalOcean marketplace. I linked to it, but you can also go to the DO website, go to marketplace in the top nav, search for Snapt or search for Nova, and you will find this one-click install. Feel free to play around for free. And then if you're interested in exploring Snapt more and exploring Nova more, I've also linked to their website as well. So plenty of different ways to interact with them. But Dave, thank you again so much. This was a fantastic presentation.
Thank you, Tim, and thanks to the DO community. Last little kind of factoid, but Nova is actually built on and runs in DigitalOcean. So, we're certainly happy with the service.
Awesome. Thank you. I appreciate that last plug. That was great. And I promise everyone I did not put Dave up to that, but thank you. And it shows.
No, it's true.
Yeah. We've had this theme of small businesses and people building things on DO. And I think you guys are a great representation of that. So thank you again for presenting. We hope this information was super helpful if you were attending, and we'll see you all on the next broadcast. Thanks and have a good day. And again, stay safe wherever you're located. We hope you're staying safe and healthy.